Assalamualaikum and hi everyone. Today I will present the introduction for our study. Bark contain various lipophilic compounds such as fatty acid, sterol, terpenoid, and resin acid. These compounds are important because they influence the chemical properties of wood and have application in industries such as pulp and paper, pharmaceutical, and bio-based materials. Due to the complex nature of this compound, advanced analytical techniques are required to analyze them accurately. Gas chromatography or GC is a separation technique used for volatile and semi-volatile organic compounds. In this method, the sample is vaporized and carried by an inert gas through a capillary column. The compounds are separated based on their boiling point and their interaction with the stationary phase inside the column. Each compound exits the column at a specific rotation time, allowing effective separation of complex mixture. Mass spectrometry is coupled with GC to identify the separated compound. As the compound leave the column, they are ionized, usually by electronic compact. The molecules break into fragments, which are then separated based on their mass to change ratio. The resulting mass spectrum acts like a fingerprint, allowing us to identify compounds by comparing them with standard library database. Flame ionization detector or FID is mainly used for quantitative analysis. In this detector, organic compounds are burned in a hydrogen air flame, producing ions. The ions current generate is proportional to the amount of carbon present in the compound. FID is highly sensitive, has a wide linear range, and is especially suitable for measuring organic compounds. GC, MS, or FID is particularly suitable for analyzing lipophilic bulk extractive because these compounds are nonpolar, thermally stable, and volatile after derivatization. GCMS provide accurate identification of individual compounds, while GCFID ensure precise quantification. The combination of this technique allow reliable qualitative and quantitative analysis of bulk extractives. This analytical approach is widely applied in wood chemistry research, environmental analysis, and natural product studies. It is also useful for evaluating the potential industrial value of bulk extractive.
The objective of this experiment are to characterize lipophilic extractives obtained from pine bark, to identify the compounds using GCMS based on retention time and mass spectral data, and to quantify the different classes of extractives using GC and ID. In addition, this study aims to investigate the effect of column temperature on chromatography separation.
Now we are going to look at the methodology. For the first method, I will start with the block diagram. The main purpose of this block diagram is to briefly explain the experimental workflow of gas chromatography analysis without sensitive technical details. So let's dive into the details of the workflow in the next slide. Next, here is the general workflow for gas chromatography, mass spectroscopy, and gas chromatography flame ionization detector. The process starts with the sample preparation, followed by sample injection and carrier gas flow. Then it proceeds to column separation and reach the detector, which is at the mass spectroscopy or flame ionization detector. Lastly, the process concludes with the data acquisition and analysis. Now we are moving on to the second part of the methodology, which is the gas chromatography, mass spectroscopy, and gas chromatography flame ionization detector. Specifically for gas chromatography, its main function is to separate volatile compound in the sample. The key components involved are the injector, the column, the carrier gas, which can be helium, hydrogen, or nitrogen, and lastly the oven for temperature programming. Moving to the detector part, specifically for gas chromatography mass spectroscopy, its function is used for the qualitative identification of the compound. The integration was achieved through the spectral library matching using the YD10 and National Institute of the Standard and Technology 11 database. In terms of performance, it effectively identified free fatty acid and lactic acid, but faced limitation with high body point compound like triglyceride due to signal instability at high temperature. Lastly, we look at the gas chromatography flame ionization detector. Its function is employed for the qualitative analysis to determine the amount of concentration of compound. The principle is that it detects organic compound through ionization in a hydrogen flame. The advantage of this detector are that the signal is proportional to the carbon content and it remains stable at the extreme temperature up to 360 degrees. This allows the qualification of steroid ester and triglyceride that were difficult to identify via mass spectrometry.
Next, for the results, we use technique gas chromatography coupled with mass spectrometry and flame ionization detector GCMS-FID. With sample we use is pine bark extract obtained using supercritical carbon dioxide, and the purpose of this result is to quantitative and qualitative analysis of lipophilic extractiveness, and the quantitative coverage is 76% detected by flame ionization detector and 57 detected by mass spectrometry. Next, to the peak identification. The highest peak is at 10.3 minutes palmitic acid in fatty acid class, followed by linoleic acid on 12.1 minutes, which also from fatty acid class, and then followed by dehydrobiatic acid at 17.5 from class fatty acid. Then the second highest is beta cytosterol at 20.4 minutes from racine acid, and lastly the lowest peak is cholesterol palmitate at 37.8 minutes, which is from class terreester. Next, effect of column temperature. The column temperature program was set initial as temperature 60 degrees Celsius isothermal for 5 minutes, and then we ramped to 380 degrees Celsius for 10 degrees Celsius per minute and maintained at 380 degrees Celsius for 8 minutes. Helium was used as a carrier gas with a gas flow of 22.5 milliliter per minute. Injection 1.0 microliter was performed by an autosampler in a cold multimode inlet, which is MMI, which was kept at 65 degrees Celsius for 6 seconds, increased to 380 degrees Celsius at 500 degrees Celsius per minute, and then held for 5 minutes with cold split injection. The split ratio was set to 15:1, which is the total analysis time was 45 minutes.
The flame ionization detector or FID burns every organic compound that comes out of the column, even a small signal. Because of its range of similar molecule in the same class, the authors could use it to calculate right amount. This is why they could report precise numbers like 2.95 milligram of triglyceride per gram of fat, even though they didn't know which exactly triglyceride they were. However, study exactly the role of GC why SE and PG were problem compound. Steroid esters and triglyceride are heavy and fragile. 380C just to edit them into free fatty acid and triglyceride. They started to break apart into vector and column. These conditions meant the mass spectrometer saw fragment, not the original molecule, so the identification failed. This is a classic GC challenge that they need high temperature to move big molecules so it can destroy them.
The application of GCMS or FID is important in bulk biorefinery and biomass valorization. These techniques support the identification and quantification of valuable bio-based compounds. These compounds have potential application in pharmaceutical, nutraceutical, cosmetic, and green chemistry industries. Accurate chemical characterization also support quality control and sustainable industrial process.
In conclusion, GCMS or FID is a powerful and effective analytical technique for the analysis of lipophilic bulk extractive. Gas chromatography enables efficient separation of complex mixture. Mass spectrometry allows accurate identification of compound, and flame ionization detection provides reliable quantification. The combined use of GCMS and GCFID enhance our understanding of the chemical composition of bulk and support its potential application in various industries. Therefore, this technique plays an important role in the comprehensive analysis of lipophilic extractive.